Hello, so this is the video that you should be watching after you have created your building or whatever you have of your spaghetti structure. And this is just a reflection point and to see, what you learned and to go over some topics that you can relate into the real life or into, reality and, why is this important? You have a spaghetti structure sitting in your room and, uh, why is it important to understand how these structures work. And at least one specific thing I think I covered in the first video just a little bit is that for earthquakes, think in a rural area you have, or not even a rural area, let's say you live in a city and you have a bunch of skyscrapers that are all going upwards as high as they can. And what you are trying to do as an engineer is to understand, if an earthquake comes, if a disaster comes, what can you do, or what are you trying to prepare for if something happens to, let's say, the to the building if an earthquake comes. And one important thing to understand is whenever skyscrapers are really tall and they're easily affected by slow moving earthquakes. So let's say an earthquake has a low frequency. Let's say it comes and it's not like shaking really fast, but rather it's very slow and calm. That's very detrimental specifically for skyscrapers because at least in most cases, whenever something is really tall, the wave that it takes to go through the building stays within the building because it has to travel all the way up to the top of the building and all the way down. That's why whenever you see skyscrapers, they or skyscrapers during an earthquake, they sway. I mean, you could look some right now, and I'll give you some time to look it up after the video. But if you just look up skyscraper during an earthquake, you'll see that they're moving very slowly, and they're not able to, I think, or if a earthquake comes, you as the engineer have to be prepared for that. And what some people, at least engineers, do is that they add a weight at the very top of the building that will evenly distribute the um, so let's say like an earthquake comes, it'll be able to even out the waves that propagate or that are within the structure and within the skyscraper. But I think another thing to know about like building this building is that the shapes that you learned and the importance of them are not just used within regular skyscrapers. They can also be used within bridges. Because let's say, I think if you look up most types of bridges, they'll all have that triangle square structure that I was talking about in the first video. And by being able to see that within your environment and being able to be like, oh, um, because there's the ability for them to not move and be more structurally sound, they are implemented in more buildings, and that's why you see as you like walk down a bridge, you see that there's triangles on the bottoms of the sides of bridges to keep it structurally sound for, let's say, really strong winds or any type of environmental disturbance or any type of like environmental effect that it has on these structures. And I think it's also nice to know how whenever there is a effect like a natural disaster or some type of event that affects your buildings, because you could put it in your own building. Let's say you grab your spaghetti tower and you start shaking it, you'll see how much it's able to withstand. And specifically engineers have done a lot to try to reduce this, because at least what structurally sound buildings do is that they implement different types of engineering topics and they implement different types of structurally sound shapes into their buildings. I also want to talk about how there's not just like skyscrapers and bridges, but within just regular homes. I mean, whenever you go and see, let's say, the beams of your own house, I mean, or theoretically, think of a house that has it's just a square. Let's say it's a square on the bottom, four walls that come upwards, and just a regular roof, a triangle or a prism roof. And you know, whenever you envision that from an engineer's perspective, you'll see that on the bottom of the house, it's concrete and that it's very stable compared to the wooden beams that support it. So the main reason for that is because let's say you use a wooden foundation instead of concrete. Now that floor is able to be water susceptible or able to have effects from the weather because of its low density, and it'll be able to be easily moved during, let's say, high winds or an earthquake. And most people don't want their house to be uplifted during just like, let's say, strong winds. So that's the key factor. So strong foundation. And that, I mean, if you look at your spaghetti tower, you'll be able to see how on the bottom you built a strong foundation. You built it by using, let's say, a triangle, a square, or any of these types. And you were able to combine these shapes together and make it structurally sound. At least you're not trying to, use it against wind or all these other types, but you basically created a preliminary foundation where it was able to be strong enough to support the rest of your tower. Because let's say you just use a square with no middle reinforcement. You could try that right now. I mean, try to remove, I mean, after you guys are done, maybe try to remove that middle beam and see what happens to your structure. Most likely, it'll just fall down because without that good bottom foundation, the rest of the tower is not able to be built correctly. And then another thing is that whenever you're building those beams that go straight upwards, those would be the beams, the wooden beams on your own house. So think of your house with those four walls that go straight up. Those four walls are able to, support that foundation that your house and support the roof, support everything else that goes upwards. And the main reason, going back to the foundation part, why you want a strong foundation is, let's say the weight of the house is supported. Everything above that house is supported on that foundation. And what you want to do is make sure that the house is able to stay structurally sound and not wobble or move, and that the foundation is able to support all of this weight that is going down on it. Because think of it, um, again, if you used a wooden foundation, all just crack and crumble from the weight of the house, and that's one key factor. And also, whenever you, let's say, envision the insides of your walls, they mainly have vertical or horizontal supports, and these are just to um, let's say if you just have four walls going upwards, those aren't going to be as strong. If you move it one direction or the other, it'll be able to fall easily. Excuse me. It'll be able to fall easily, and you know it's not going to be a good house. It's not going to be able to stay online or stay upright for a long amount of time. And that's why you use supports between these beams. So you have two beams that are right here, two walls. You use horizontal supports, you use vertical supports, you use diagonal supports. And all of these are able to support those two walls between this house. And I think because of that, you know, these houses are able to be supported and, as I said before, structurally sound. And I think after you've figured all of that out, you'll be able to not only create more, but envision buildings differently. Because I bet you right now you've just looked at your house as a couple walls rather than, let's say, horizontal structures and horizontal beams that support it. Or let's say you look at a bridge, you just see walls and metal, or not walls, sorry, pillars of metal, or different types of structural shapes. And you're like, why do they use triangles over squares? And it's mainly because of what I said before. Or why do they use tension, or why do they use all these different types of things? And the spaghetti structure you made is the very basic type of structure. Because if you think about it, there's so many other different materials you can use for buildings. There's so many different other shapes that you can use, although the triangle is most recommended. There's so many other types of designs that are implemented, or different types of engineering concepts. And if you're curious about it, you could go, look some up and learn more about what engineers use. I think I could cover some here. If you think about it from, let's say, what else is there? You got bridges, you got skyscrapers, um, let's say you got maybe a cabinet, a wooden, or no, let's say you got a table. You could see the same thing inside of your own table to keep it upright. You have support beams that are evenly distributing the weight from the top of the structure all the way down to the bottom. And if you only have four beams that go downwards, although most tables usually do stay upwards with four beams, it's because of those four structures that's able to support it. And that's why you see some tables that have a middle support, because if you have two sections only here, that leaves the middle empty for a table to just tilt inwards. Because let's say you have something heavy like a computer monitor weighing on that table, or let's say you have other things that are heavy, um, it would be a liability, or it'll be not great for the table to be structurally sound and be staying upright like that. And I think if you think about it more and think about the different types of shapes, not shapes, the different types of products that you use on a daily basis, everything has these fundamental structures within them. And there's also different types of engineering concepts that you haven't learned yet, but hopefully you will learn in the couple next lessons. So yeah, thank you for coming to the very first class and very first lecture for the spaghetti structure and for the virtual makerspace engineering course. I hope you see you in the next one. Bye bye.